Alright, honors kiddos, it's test time. So this is a question that is related to our honors study guide question. So it's unique to you guys only. Okay, so honors only need to be watching this. So we're going to be looking at how a parabola can be used to model the arch that supports a bridge. So we have our road up here, and then you have an arch supporting it, and then there's your concrete or bricks. Alright. So, on this bridge, the keystone of the bridge, or the vertex of it, is at 30, -7. So it's 7 feet below the road, and it's 30 feet from the side. The endpoints of our arch are represented by 0, -12, and 60, -12. Alright, so I always like making a visual of what we're talking about. Now, how would we determine our domain? Well, this parabola would not go on forever because your bridge does not extend down into the ground. So domain, remember domain are my inputs or my horizontal component. So what is my horizontal component? Well, I start from 0. I start from a distance of 0, so that's the left side of my bridge, and I keep going, and I keep going until I'm 60 feet away. When I'm 60 feet away, my arch ends, and that's it. It doesn't continue. It does reach 0, and it does reach 60, so we include those. So I have 0 less than or equal to x less than or equal to 60. Notice it's always a starting point, which is our smaller point, over to our larger point, or end point. Now, what does the transform equation of a parabola look like? If you look at 1.3, explain 3 in your notes. That's related to this question. If we're talking about a modeling problem, in modeling problems, we assume the b to be 1. So we're just going to have a quantity, x minus h squared plus k. The quantity squared is because we're talking about parabolas. And parabolas are represented by x squared. Parabolas are represented by x squared. So that is where the quantity squared is coming from. Okay, so instead of f of x, I can put quantity squared. Or, if you wanted to represent it as g of x equals a f of x minus h plus k, you could do that as well, where f of x is x squared, quantity squared. Alright, so either way of representing the quadratic is just fine. They are equivalent to one another. This one just fills in the parent function, and I know it's x squared because it says the word parabola. Or I could just use f of x notation. But notice in both scenarios I don't have b, because for modeling problems we assume b to be 1. We can include all stretches and compressions within the a value. Now remember, vertex is the max or min of our parabola. It is the highest or lowest point. And the vertex is always represented as h, k. So what information does it give us about our equation? It gives us the horizontal translation and the vertical translation. So it tells us the horizontal translation and the vertical translation. Love the glitches. Here we go. So in this case, my vertex is 30, -7. So my h is 30, my k is -7. So I know h is 30 and k is -7. I know that because I am told the vertex is 30, -7. So that means the information I know so far I know that g of x equals, I don't know the a value, and I'll go ahead and, since your book example looks like this, I'm going to go ahead and use the f of x notation. F of x minus, and I can replace h with 30, and plus k, but k is negative, so I'm going to put minus 7. Alright, now to be able to solve, I'm going to substitute one other point. You could substitute in either point. It does not matter which other point you plug in, but plug in one with nicer numbers if it's available. So I'm going to plug in 0, comma, negative 12, just because those numbers are a little nicer. 0 is my x value. Negative 12 is my g of x. Notice g of x. This is a single object, a name. G, the function of x. So this whole thing is going to become negative 12. So now I make that negative 12 equals, I still don't know what a is, but I get f of, and I'm plugging in x value of 0. So 0 minus 30. Subtract 7. Alright, I need to isolate the a, and these are grouped together by multiplication right now, so I start by trying to isolate them. So I get rid of the subtraction by adding to both sides. So I'm going to get negative 5 equals a, still don't know what my a is, times f of, and 0 subtract 30 is negative 30. Now at this point, what is f of negative 30? What is f of negative 30? Well, f of x is my parent function, and what is my parent function? X squared. So f of x is x squared, so f of negative 30 is quantity negative 30 squared. You need it in parentheses, because negative 30 squared is negative 30 times negative 30 equals 900. Equals 900. So I have negative 5 equals a times 900. A is being multiplied by 900, so now I'm going to divide both sides by that amount. I'm going to divide both sides by 900. So I get negative 5 over 900 equals a. We are almost done. I want you to remember to simplify. Simplify your fractions. We are Algebra 2 honors kids. We should be simplifying our fractions. So if a equals negative 5 over 900, both of these numbers are divisible by 5. So I have negative 1 over, and when I do 900 divided by 5, 5 goes into 9 once. Oops. 5 goes into 48 times. And 5 goes into this last 0 0 times. So I get negative 1 over 180. This is not my answer. This is my a value. To get my final answer, I'm going to go back to my original function, my original start to my function. I'm going to go back up here to this function, and I'm now going to get rid of that a and plug in what we know it to be. So now I know this function should look like g of x equals, and instead of a, I'm now going to put negative 1 over 180, f of quantity x minus 30, because standard form has a minus h, close my quantity, subtract 7. Here is my final answer. Here is my final answer. Okay, now there is a second answer I would accept. Okay, if you decided to use the x squared notation all along, then your final answer would have looked like g of x equals negative 1 over 180 quantity x minus 30 squared, so there's my function squared, minus 7. Both of these would have been acceptable answers. So notice a bit of work is definitely involved to solve for A. There is no easy way around finding it other than to solve the equation. Now if you would like to, you could always, well, for the study guide, if you're practicing again, you could always confirm an answer by graphing it and see if that graph makes sense and if the points land on there. So I can go ahead and head over to Desmos. And on Desmos, I can type it in and see if the graph makes sense and if my points are on it. So I have negative 1 over 180, right arrow to get out of it, quantity x minus 30 squared minus 7. Oh no, I don't see my graph. Well, I can change my graph settings, and I know I want my x-axis to go from 0 until 60 because my domain. And so I know my outputs went from negative 12 to negative 7. And even I could go all the way to 0 just because then you could see the road and see if we like that. Okay, and then if you want to see beyond it a bit, you could always extend it out. Alright, and I could also restrict my domain on this. I could restrict my domain. But let's check the points on this. Let's check our points. Let's see if 0, comma, negative 12 is on the graph. Notice the blue point landed. Alright, let's look at 30, comma, negative 7. There it goes. It showed up on the graph. And 60, comma, negative 12. Notice all 3 points did land on the graph, so we wrote our equation correctly.